In this lecture, we will learn about nanomechanics. Because of emergence of nanomaterials, it becomes important to learn about what is happening at the nanoscale and to also extract properties, mechanical properties such as hardness, modulus, how does it vary with respect to different nano phases which are present in a bulk nanostructured material. So, in this lecture, we will learn about nanomechanics, specifically about nano indentation in order to extract hardness and Young's modulus out of these materials. Nanomechanics is the field of technology which involves forces in the order of nanonewtons or displacements which are to the order of nanometers. So, that is why nanomechanics will deal with materials which are which have a nano size, nanometer size, so that we can specifically design this instrumentation so that we can precisely measure what are the displacements or the forces which have been incurred by that particular phase which is in the nanometer size range. It also is utilized for fabrication of new materials or scanning a particular property out of it or scanning the morphology or the topography out of it. Also sensing, because once we talk about nanotechnology, we also need to sense what sort of forces which are incurring on a particular material. So, in order to comprise the fabrication, scanning, sensing, the nanomechanics becomes a very essential tool. Learning about nanomechanics. It can again be non-contact. In that case, we can utilize van der Waals forces, which is again in the non-contact mode. Like we can utilize atomic force microscopy, and we can utilize the non-contact mode in terms of imaging the topography. Or it can again be in the contact mode, like for nano indentation. So, coming in contact with the material and then extracting the properties or mechanical properties out of it. So, we can see nanomechanics is a very essential way of learning about what is the response of a nanomaterial. It can be nano phases and how do they incorporate in terms of evincing the bulk properties. So, we can have a nano properties of each and every individual phase plus contribution of some additional forces, such as it can be just porosity or say interaction between the two grains which are in nano size. So, that can finally evince the bulk property. So, once we know what is the response at a nanometer length scale, we can somehow build them up by using a multi-line scale hierarchy to achieve a bulk property out of that. So, nanomechanics is a very essential means of comprising what is happening at nanoscale and predicting what can happen at the bulk scale. And again, as we see that it is utilized for fabrication or even scanning or even sensing. Majorly in this lecture, we will learn about nano indentation. So, let us see about that. So, nano indentation is utilized for measuring the mechanical properties of thin films, coatings or even smaller volumes. So, see if you have a microstructure and where the faces are in the nano regime, and if you want to extract what is happening or what is the change in the mechanical property because of those particular faces, we need to see what is the property of individual phases. Like we have phase A. So, like we have phase A and we have phase B, and assuming that the overall length scale is couple of nanometer. So, then once we make a tensile bar specimen, it will give us a property of the bulk. So, we can get a overall property of the bulk using the tensile bar specimen, which can provide us modulus of the system or stress strain relationship. But if we want to see what is happening, what is the contribution from each and every individual phase, like of phase A and phase B, we need to do the nano indentation. So, we can evince or we can extract the properties out of individual phases. Again, if we have a coating, if you have a very thin coating to the order of couple of nanometers or submicron range, it will say if it is very adherent to the substrate. So, we have a substrate and we have a coating, and we want to see what is the response of this coating with respect to the substrate. We might do a tensile bar specimen, tensile bar testing, but we want to see what is the contribution of coating alone. Then it is very hard, because even if you do indentation, a micro indentation, that might actually have some influence from the substrate also, because the coating thickness has to be independent, because if we are the thickness of this coating has to be independent, it has to be thick enough so that we do not see any response from the substrate, but that may not be in reality, that may not occur in reality when we have a submicron size coating on a particular substrate. So, in those cases nano notation becomes very essential, because if you want to extract the properties, the indent or the depth of the indent should be smaller than at least 7 to 10 times of the entire coating thickness. So, that in that way we can avoid the contribution from the substrate, and we can get properties only with respect to the coating and not the substrate. So, in order to calculate or measure the mechanical properties of thin films or coatings or even smaller volumes, so in this case if we have a phase A and phase B, these are very small volumes, because we are talking about grain size which is to the order of couple of nanometers. So, we can individually go to a particular spot and do the indentation at those particular points. So, what we can get is property with property of that individual grain